Hi everyone, welcome to my YouTube channel called Math with Vanj. My name is Vanj and I will be teaching you math, obviously. So we will be starting with the AP Calculus curriculum, and this is a course which can be challenging for a lot of people, and I hope that my videos can be helpful to those who are currently enrolled in the course or plan to take it in the future and want to get a head start. So we will be starting with Unit 1 of the Calculus curriculum because it really doesn't make sense to start anywhere else. And this unit deals with limits and continuity. So if you're ready, I am too, so let's get started. Okay, I lied. So before we get started, we need to define what calculus actually is. So calculus is basically split up into two different branches, differential calculus and integral calculus, right? So differential calculus is all about finding the rate of change of a variable over time. Now this sounds pretty familiar to something we did in algebra, finding the slope. And yeah, that's basically what differential calculus is. It's finding the slope. Except the difference is, in Algebra 1, you found the slope between maybe 2 points, like of a line. So if you had a line y equals x, and you wanted to find the slope, you would take 2 points, x2, y2, and x1, y1, and then you would subtract y2 minus y1, and then over x2 minus x1, and this would give you your slope, right? So what's different in calculus? In calculus, it's finding the instantaneous rate of change. So instead of given 2 points, if we were only given 1. Now, since this is a line, this looks pretty easy to do. But suppose we had a curve, like y squared, or x squared. So if we had a curve like y equals x squared, in algebra, maybe we would find the slope between this point and this point. So here we would do the same thing, y2 minus y1 over x2 minus x1, and this would give us our slope of our secant line. But in calculus, if we wanted to find the slope, we would do the slope of a point. That would be if we wanted the slope of this point right here. So this point would have a slope like that, the tangent line. So in calculus, we find the slope of a tangent line rather than a secant line. Now, integral calculus is completely different, except not really, as we'll see in later videos. Integral calculus is all about finding the area under a curve. So like in geometry, we found the area of squares, rectangles, triangles, all those like regular shapes, right? In integral calculus, we'll find the area under a curve, which is going to be an irregular shape. So suppose we'll do the same curve, right? X squared. Suppose we wanted to find the area under the curve from 0 to 3 right here. So then we would find this area right there. So that's what integral calculus is. Now both of these branches of calculus are absolutely nothing without limits. So let's define what a limit is. This, what I've written, is the official College Board definition of a limit, and it is if f of x approaches a certain y value as x becomes arbitrarily close to a certain x value, the limit as x approaches that x value is the certain y value. So what does that mean? So we know what f of x is, right? We know f of x is just our function or our graph. And as that function approaches a certain y value, as x becomes arbitrarily close. So what does arbitrarily mean? Arbitrarily means basically really, really close. You could even say infinitely close to a certain x value, and it can be any x value. Then the limit as x approaches that x value is the certain y value. So let's say that this certain y value, we'll call this L. So this is L. And we'll say that the certain x value is C. Okay? So we'll call it C. So the way to write this is the limit, LIM is short, I'll make that bigger. LIM as x approaches c, and c is that certain x value, of the function f of x equals the certain y value, which is L. Okay? These two are the same thing. This is just saying the limit as x approaches c of f of x is equal to L. So that's what that means. So let's take an example. So suppose we had f of x equals x squared, right? We'll just use the same example that we've been using. So we have a graph, right? 1, 2, 3, 4. 1, 2, 3, 4. And then, yeah, we'll go -2. And then, so we know here, here, and then here, right here. So it's going to go like that, and then like that. And suppose we wanted to find the limit as x approaches 1 of f of x, and we wanted to find this. So, well, that's easy. We can see that x approaches 1 is right here, and we can see that from both sides, as x gets really, really, really close to this x value, x equals 1, we can see that the limit is 1 right here. That equals 1. Now, it's really important that the limit as x approaches 1 of f of x approaches the same value from both sides. If it didn't approach the same value from both sides, then the limit would not be true. We can take another example. Suppose we had a piecewise function. Suppose we had the same thing, x squared, when x is not equal to 2, right? And suppose we have 1 when x equals 2. So what would this look like? This would be same thing. It would be, and then we'll go by 2's this time. 2, 4, 6, 8. And then it would be something like that and like that. So when x equals 2, we don't have a value. This is going to be a hole right here in the graph. But we know that it equals 1. So that's going to be right here, right? And suppose we wanted to find the limit as x approaches 2 of f of x. And we want to know what that was. Now, even though the actual function equals 1 when f of x is 2, the function approaches from both sides this value of 4 right here. Remember, we're going by 2's. So this function approaches this value of 4. So even though the actual function equals 1 when x equals 2, the limit as x approaches 2 of f of x would be 4. So that's basically what a limit is. It's the idea of getting really, really close to a certain x value and finding out what the y value approaches as we get really close to that x value. There's 3 kind of requirements for a limit. The first requirement is that as x approaches c from the right, so from the right, and as x approaches c from the left, these two have to be equal. So the limit as x approaches c from the right and the limit as x approaches c from the left, they both have to be equal. And there are ways to write one-sided limits. These are called one-sided limits as x approaches from one direction or the other. So if we have a one-sided limit and it's approaching from the right, that would be written as the limit as x approaches c positive, because we're coming from the positive direction, right? And then of f of x equals L. And then if we were approaching from the left, it would be the limit as x approaches c negative. Negative because we're approaching from the negative side of f of x equals L. So this requirement is saying that this limit and this limit both have to be equal. Now, when's a example when these two limits aren't equal? So suppose we had another piecewise function. Suppose we had f of x, and we'll do two lines this time. So 2x and x minus 2. 2x is when x is less than 1, and x minus 2 is when x is greater than or equal to 1. So what would this graph look like? This graph would look something like this is 2x right here, and we only want when x is less than 1. So this is going to be a hole right here, and then x is greater than or equal to 1, we have x minus 2. So x minus 2 So x minus 2, if we go down here, it's going to be right here, and then it's going to be going like that, right? And it's only when x is greater than or equal to 1. So we would have a filled in bubble right here, and then like that. Okay, so this is what this graph would look like. 2x as x is less than 1, which is right here, and then x minus 2 as x is greater than or equal to 1, which is right here. Okay, so suppose we wanted to find the limit as x approaches 1 from the positive side, and the limit as x approaches 1 from the negative side. Okay, so as f of x, as x approaches 1 from the positive side, that's coming from the positive direction, so this way. So this is positive. So what does this equal? We can see that this gets closer and closer to this y value right here, and this y value is 1. And we can just plug that in to see that. Sorry, not 1, negative 1. And we can just plug that in to see that, because 1 minus 2 is negative 1. So we can see that the limit as x approaches 1 from the positive side is negative 1. Now, same thing as x approaches 1 from the negative side, we can see if we follow this line, if we go this way, we can see that even though there's a hole at this point, it's still technically approaching that point, because in a limit, we're never exactly at that point. We're just getting really, really close to that point. So we still, right here, we can see that this would be 2. And we can also plug in right here. If we plugged in x equals 1, we would see that f of x would equal 2. So we can see that the limit as x approaches 1 from the negative side or from the left is going to be 2. Now, if we wanted to find the limit as x approaches 1 from both sides, if there's neither a positive or negative in front of the 1, that means we're saying from both sides. And if we wanted to find what that equals, then we have to see. Well, the limit as x approaches from the right is negative 1, and the limit as x approaches 1 from the left is 2. And since those aren't equal, we can't say that this exists. So we're going to say does not exist, or D and E. So although both of these values exist, the limit as x approaches 1 of f of x does not exist. And one last example, we can say another piecewise suppose we'll do a simple one. F of x equals x when x is less than or equal to 2. And we'll just say 2 when x is greater than 2. So what would this look like? So same thing, let's make our graph. This would look like this, and I'm just going to freehand it for now here. And then we'll say that the line 2 is right here. We'll say that x equals 2 is right here. So this is x equals 2. So then this is what our graph would look like. Okay, and this y value right here is 2. Okay, so this is our f of x equals x, and this is our f of x equals 2. So now we can do the same thing. Suppose we wanted the limit as x approaches 2 from the positive side of f of x. Well, this would equal, if we come from the positive side, we're coming from this side, and we can see that this line approaches 2 because it's always 2. So this is going to be 2. And now same thing, if we want the limit as x approaches 2 from the negative side, we would have f of x, and this is also approaching 2 because if we come from the left or from the negative, this also approaches 2. So now if we wanted the limit as x approaches 2 from both sides, we can see that both of these are equal, so it does exist, and it would just be that value. So since the limit as x approaches 2 from the right side equals the limit as x approaches 2 from the negative side, we can just say that the limit as x approaches 2 from both sides is 2. Now that is all you need to know for the first part of limits and continuity, the definition of limits and how they work. In the next video, we will be covering how to solve for these limits in 3 different ways. There's graphical, using a table, and analytical. So that's what we will be covering in the next video. Hope to see you then.